Hi, in this video I will show you how we can use the library EloquentTinyML Machine Learning. This library allows us to run TensorFlow-like models into ESP32 boards or Arduino Nano 33 license and another boards. But in this example, I will show you how we can run one model from TensorFlow into one ESP32. Okay, the first step to do this, what we are going to do is train our model. I will use one dataset with fake values. Basically, I have random values. I am simulating one moisture sensor. You can see my dataset. The class 1 is for values which are higher than 50, which means that there is moisture in the soil, but lower values than 50 means a dry soil. I have 100 random samples, and this I'm going to use these values. You can see I have two classes. Class 1 for moisture and class 0 for dry soil. Therefore, I will use one sigmoid function. Values nearest to 1 will mean a prediction that this is a moisture. There is moisture from the sensor. And if the value is lower than 0.50, means a zero class or dry soil. And therefore, I don't need to drain with water my soil. Okay. Now I will show you the Python code to train our model. Here we are inside of Google Colab, and early I loaded my dataset. This is my dataset. This is a CSV file. This dataset was uploaded here. Let's get started. First, we need to import our main libraries that we are going to use. In this case, I will use pandas to load our dataset TensorFlow to train our model and create our model, and keras to append layers to our model. Let's start importing these libraries. Sorry, I forgot run this cell. Basically, it means for tell the Colab that we are going to use TensorFlow version 2.x and not another version. Okay, that was done. Now we are going to load our dataset. Let me see. Okay, now we are going to create our model. As I have only one input, my first layer is of a shape of one input. And then I have 64 dense neurons with activation function relu. Then I have, at the end, I only have one dense layer with activation function sigmoid. And then we compile the model with binary cross entropy loss function, and the optimizer is Rho mean square root. And the metrics to evaluate our model is the accuracy. I'm going to run this cell. Okay, then I need to train our model. The training has started. I'm going to pause this video. Okay, I got one accuracy near to 100%. The loss decreased when the epochs were increasing. This is the minimum loss. Okay, now that we have trained our model, we need to convert this model into a TensorFlow-like model. I'm going to run this cell. This will convert our model to a TensorFlow-like, and then it will save this model in this file with this extension, tflite. Let's run this. Okay. According to the documentation of the EloquentTiny machine learning library, to convert our model to a CRI, it says that we need to use this library, Tiny Machine Learning Gen, TinyML Gen. But you will see that for me it will not work, because I will get none values in the predictions. But I'm going to run this to show you the problem. Okay, guys. Then I'm going to now we have our TF-like model. Here we have with this name, moisture sensor. And then we are going to convert our model to a CRI. To do that, we need to install this library, TinyML Gen. I will install it according to documentation. Okay. Then we need to execute this, and then okay, guys, now we have this new code with our model in a CRI. Here you can see. Okay, now we need to create one file with a name. In my case, I call this file sensors_model. I'm going to remove this. You need to create inside your Arduino project. This is the project folder, and here we have one file with the name sensorModel.h. Just create this file, and inside this file we need to paste all this content from the library that we have installed. Copy this and paste here. Then give a name, sensor model, for this array. This file will be imported inside of our main file with extension .ino. Okay, this is the basic script to make the predictions. This is the main file. First, we need to import the library EloquentTinyMachineLearning.h and this second library. But first, we need to install this library. According to documentation, this documentation is not updated. You can see that here recommends that we need to use the version 2.4.0, but now this library has a newer version. Just share here Eloquent, and you can see here EloquentTinyML, and now it is in the version 2.4.3, but the documentation recommends install 2.4.0. No problems with this code with these versions. I will use the latest version. 2.4.3, there will no problems. The unique problem is that this documentation recommends generate or CRI using this library, but for me it doesn't work. I will show you the solution for this case that works. Okay, I have installed this version 2.4.3, and that's it. Just import these libraries, then import our model. Remember, use this name, give a name to our model, and then declare the number of inputs, the number of outputs, and one buffer size for our model. You can increase this buffer size if you need more power. But basically, I will left this value in this case. Then we need to instantiate our TensorFlow library. Okay, here we pass the number of inputs, the number of outputs, and the tensor arena size, which means the buffer for this code. Here we create this variable tf. If you need to use a lower version than 2.4.0, like 0.05, you need to comment this and uncomment this, and also comment this. But as we have the last version, we need to use these two libraries, and we need it. Then in the setup method, just start the serial communication and print some message and start the model, calling to Beijing method. And inside of the loop method is where we are going to do the predictions. Okay, guys. Here basically I am writing the serial values from the serial monitor. I just read this one value in float format, and then I create one array of one size, one input, and I just pass this value from the serial monitor. Then I just print some messages, and then I did the prediction. This is how we can do the predictions. Just create one variable to set the output and call the method predict, and just pass the input. Here is the input, and that's it. And then I just create one condition for just show one message, some message. This is my threshold value for the moisture. If the prediction value is higher than 0.50, I just say there is moisture. There is moisture. Is lower than 0.50, just we say drying water. If you need to pass more inputs, just pass here. Just declare the number of inputs, for example 3 inputs. I think that is of this way: input 1, input 2, and input 3, of this way. But in my case, I just have one input. And if you have many outputs, you declare one array of many outputs as you want and say the outputs. Now I'm going to test this code, but remember that, as I said before, when I generate the CRI, in my case, this code gives me NaN values, NaN values. I'm going to upload this code. To fix this problem, just we need to replace this array. Later I will explain how to do that. Now the code is being uploaded. The code is compiling. I forgot to say you that this library, EloquentTinyML library, is a compiled library of TensorFlow for ESP32 boards and other boards. We don't need to compile this library. It's already compiled. Don't worry about it. This library is just facilitating our work. And only we need to write some line of code to do the predictions. You can see here that it's a very tiny code. We don't need many code. It's pretty easy. I'm going to pause this. Okay guys, the code has been uploaded inside the board. Now I'm going to open the serial monitor. According to the code, it should say this message: loading model and model loaded. This is in Spanish, sorry. I forgot to change it. But now the code is not started. I'm going to start this code of the board. I'm going to press the reset button. Just press this button. And now this is the message in Spanish: model loaded. Now I'm going to send some value to predict. I'm going to look my dataset. Here, if I pass 78, the class will be 1, or there is moisture in the soil. I'm going to pass 78. I'm going to press enter. This is a message, and here's the prediction. This is the problem. As I said before, this library is creating a wrong model, a wrong CRI model, tiny engine. I'm going to send another number. You will see again a NaN value. Okay guys, but we are going to fix this problem. To fix this problem, we need to install this Linux library XXD. I will predict before. I forgot predict. I just going to predict again. This is one example. This is class 1 or moisture class. Okay, I'm going to generate again my CRI using this new program. This is XXD, and this will works. Okay, this will be installed, and then we execute this command XXD and we pass the name of the TFLite model which was generated before. Here is the file, and we pass here the name and the extension and the symbol, and then the name of the file that will be generated. But basically we are going to copy this array, and we are going to replace that value. Okay guys, let's go and execute this code. Okay, this finished. Now, as I said before, just copy this. I'm going to close this. We are going to replace this. Remove all this array. Just the content, guys. Okay. And paste here the new value. And then don't forget to update this length of the array. The new length, as you can see, is 2500, and the old value was 2608. The values are different. That's it. Let's to update this program inside the board. Okay guys, I'm going to pause this video. Okay guys, now the code is being uploaded. Now has been uploaded. Now I'm going to open the serial monitor. Now I'm going to press the reset button of the ESP32 board. and the model has been in it. Now it's moment to predict some values. I'm going to predict 75 and the class will be 1, or a value near to 1. 79 was 75, sorry. I just press enter, writing, and you can see, guys, the prediction is 1. Means that now our model is predicting successfully our inputs. I'm going to pass. It is simulating one moisture sensor. I'm going to suppose that this is a value from the sensor. This is the soil sensor. This is the moisture's value, and this is the prediction. And then there is moisture. But what happens if I pass a moisture value of 45? Means that the system should be drying water. You can see this value, the prediction was a value very lower. I'm going to pass this value inside the collat. This is 45. Sorry, 45. See, 45. You will see a very low value, 0.48. But this model is, sorry, 0.8 was a prediction. But before, sorry, this message are sorry, I don't know how to say this, but when we send one value, Arduino IDE is sending another value with new values. This is our input, and this is an empty input. It is a bug inside the code, but it's not important. That important is that we send our input and we can see the prediction. Okay, guys, I hope that this video was useful for you, and I hope that you have learned something in this video. I hope that you can implement this inside your project, in your projects. That's it, guys. If you like this video, leave your like. If you wanna if you want to comment, you comment. You are free of comment. You are free of leave any comment. Free of ask me any question. I will ask you. I will reply you in any moment as I am available. That's it, guys. I hope that have you enjoyed this. I will share this code. I will share the project, and don't worry about it. See you in another video. Thank you so much. Bye bye.